Good afternoon, ladies and gentlemen. Thank you for being here with me today. Let us analyze the country of Haiti as a source of research for potentially turning rocks into renewable energy with hydrogen breakthrough. On a recent report by SkyTech Daily, which came out on March 31st, 2024, we learned that researchers at the University of Texas are pioneering a method to produce hydrogen from iron rich rocks without carbon dioxide, potentially revolutionizing the hydrogen industry. Researchers are exploring a suite of natural catalysts to help produce hydrogen gas from iron rich rocks without emitting carbon dioxide. If successful, such project could jumpstart a brand new type of hydrogen, geologic hydrogen. According to Toti Larson, a research associate professor at the University of Texas, this project is, quote, a type of non-fossil fuel production of hydrogen from iron-rich rocks that has never been attempted at an industrial scale, end quote. Hydrogen is an important player in the energy transition because it does not produce carbon dioxide gas emission when it's burned for fuel. Its only byproduct is water. However, most hydrogen gas is produced from natural gas in a process that also produces carbon dioxide. Reread. Producing geologic hydrogen from iron-rich rocks would offer a major shift in the energy transition because of its low carbon emission footprint. The technique is to replace hydrogen that is sourced from fossil fuels with hydrogen sourced from iron-rich rocks. Furthermore, we read that the catalyst the team is exploring will stimulate a natural geologic process called serpentinization. During this process, iron-rich rocks release hydrogen as a byproduct of chemical reactions. The research team is working to stimulate hydrogen production at lower temperatures and at depth easily accessible by today's technology, where iron-rich rocks are found throughout the world, meaning catalyst enhanced production of hydrogen from iron-rich rocks has the potential to significantly increase hydrogen production globally. Le Massif de la Route, located in the country of Ayiti, more precisely in its southern peninsula, occupied by two valleys and bathed on three other sides by the sea, it has a high chain of 2,405-meter altitude at Peak Makaya. Looking at the general geology of the Massif de la Route, we learn that there are various forms of sedimentary rocks that are formed. All systems from the Cretaceous to the recent are represented in the Massif de la Route. The Makaya Formation is covered in angular unconformity by Cenozoic sedimentary formation. Cretaceous volcanic rock seems to cover it. A small outcrop of dark gray crystalline rocks which appear to come from the metamorphosing of detrital sedimentary rocks is also found in the Massif de la Route. Outside of the sedimentary rocks, we also find the igneous rock, which are represented by volcanic rocks with intrusive rocks, providing only a small number of outcrops of limited extent. We also find the basaltic rocks, some with small amount of olivine, others rich in olivine. Andesitic rocks, dolerite rocks, as well as dacitic rocks are all found on the Massif de la Route. The Massif de la Selle constitutes the eastern part of the southern peninsula and extends eastward to the Dominican Republic border, which separate it from its structural extension, the Baoco Sierra. In the Massif de la Selle, we also find sedimentary rocks. All systems from the Cretaceous to the recent are represented, with the exception of the Oligocene. We also find igneous rock, basaltic and doleritic rocks. Ayiti is one locality which should be considered and explored for the studies of renewable energy with hydrogen breakthrough. It is highly possible that those geological aspects of the country will help propel into the aspect of geologic hydrogen. Thank you so much for listening to me, ladies and gentlemen. I will see you in the next.